Should we rename Uranus and stop making fun of its name? How will astronomers deal with the flood of data when Vera Rubin comes online? Do little red dots found by Webb solve the mystery of supermassive black hole formation? And in our free Q&A Plus on Patreon, what are my personal space obsessions right now? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Kristin Holcomb, do you think the discovery of black holes in the middle of big red dots explain how black holes appear in the centers of galaxies? So this thing, and it's little red dots, and this was an entirely new class of astronomical object that was discovered by the James Webb Space Telescope. And so when Webb was doing one of its surveys of the distant universe, looking at the farthest galaxies that it could possibly see, they found a bunch of these weird red, and even red, it's an infrared, but they're redder than other galaxies, and they're very small. And astronomers were trying to figure out what these things were. And the sort of conclusion that they've reached now is that these are galaxies that are black hole heavy. So they're fairly small, probably like dwarf galaxies, but they have a surprisingly massive supermassive black hole at the hearts of them compared to the mass of the rest of the galaxy. And then the region around the black hole is shrouded in dust. And so that's putting out a lot of infrared light that is then being redshifted compared to other galaxies. But this is we're at the very early stages of figuring out what these things are, because it's right out at the very edge of what James Webb can see. And James Webb is the most powerful space telescope ever built, designed for this exact purpose. But there's sort of a very interesting things that people are finding early on in the universe. Right now, the Milky Way has a supermassive black hole at the heart of it. And it is about 0.1% the mass of the galaxy is tied up in that black hole. And so, people always think, what would happen to the Milky Way if it lost its supermassive black hole? Nothing. It is not the anchor. It is not the bulk of the mass of the Milky Way. It is one tiny little bit of the mass of the Milky Way. But when you go back early on in the universe, the ratio of black hole to the rest of the galaxy seems to go up. And when you get all the way back to these little red dots, you're looking at black holes that are 10% the mass of the galaxy, half the mass of the galaxy. And so one of the big fundamental questions that James Webb is trying to answer is, how did those first galaxies come together? We know that there are supermassive black holes at the hearts of pretty much every single galaxy in the universe. And so the question is, did the black hole come first and then it assembled a galaxy around it? Or did the galaxy come together first and then the various black holes, stars detonated, turned into black holes, the black holes merged together, formed larger black holes, and eventually, it all sunk down to the middle and you got this supermassive black hole. And so if you're seeing a much more massive black hole compared to the mass of the galaxy, it's starting to give credence to the idea that these supermassive black holes were starting to form first. And then the rest of the galaxy was starting to accrete around it. And that's weird, because you would think that for you to be able to get a supermassive black hole, you would have to go through this process of chaining together a whole bunch of smaller black. You'd have the first generation of stars, they would explode as supernova. Maybe some of them would leave behind black holes. Those black holes would find each other. They would merge into bigger black holes, and you would sort of go through this geometric progression until you finally reach things with tens of millions, hundreds of millions of times the mass of the sun, even billions of times the mass of the sun. But the other possibility is that if the conditions are right, you could get supermassive black holes just forming directly. It's called direct collapse. And what they think, this is difficult to achieve, because as you have material that is infalling to some region of space, that region heats up. And as soon as it heats up to a certain point, then that blocks and prevents any further material from infalling into it. And then that sort of puts a limit at the size of the star that is possible to be made. And, those limits are around 100 times the mass of the sun. And so, how are you going to get a supermassive black hole when you're limiting the amount of mass to about 100 times the mass of the sun? Actually, those most massive stars, when they detonate, they don't leave any remnant behind. So you need smaller mass stars that can then leave black holes that can merge together. But maybe there's some kind of cooling effect, some kind of way that when the black holes were forming early on in the universe out of primordial or hydrogen and helium, as that material was falling in, it was able to, get rid of the waste heat so that material could actually efficiently come together and actually pack down into an area that would turn directly into a black hole. And that would give you a really nice answer. So, James Webb is designed to answer these kinds of questions. And so now finally, we can go from theory to actual observations. And, I think over the coming years, we will get some really good answers to these kinds of questions and more. Astrophotography. Hey, Fraser, when LSST comes online, how will astronomers deal with enormous amounts of data? Will there be more citizen science projects based on the LSST data? LSST, aka Vera Rubin, will be producing a ludicrous amount of data. It would wreck your bandwidth bill if you try to download the data. So what they're going to do is two things. They're going to create a highlight reel of data from Vera Rubin, where they're going to have various algorithms that are looking through the new stuff that's being found, and then it's going to be made available in one stream. And so you go and see it, and it'll say like new supernova and new asteroid and planet 9 and all of this kind of stuff. And so all the highlights will be there, but then all the underlying data will be there as well. And so if somebody wants to do a really comprehensive survey looking for interesting things that have happened in the sky, show me all of the variable stars that occurred in this region of the sky during this period, it will be able to find all of that. But you're going to have to run gigantic database queries. So handling all of this data is a big chunk of what it is like the underlying technology that the people who are creating this observatory are having to manage. How do you let astronomers feasibly search through that much information? I'm going to be interviewing the director of Vera Rubin in a couple of weeks. So these are the kinds of questions that I'm absolutely going to be asking them. It's time to shout out our new patrons at the $5 level and above. Marty S., Curveball, Jacob Beal, Sage of Roca Sika, Ben, Brett Coriel, Catherine Scott, Jack Prime, Oligator, and JC Woodward. Join our community at patreon.com/universetoday. Ian James, why do governments need to fund space science or exploration? Why can't it come from private industry investing in a product or service? So many of the most incredible inventions and discoveries that have been made by humanity have been made in a way where there is no commercial purpose. We live in this modern age with computers and the internet and satellites and radio waves and semiconductors and various medical technology and all of this stuff, physics, antimatter, all this came from basic research where somebody just had a question. How does this work? How does the human brain work? How does the universe work? How does light move? What is matter made up of? What happens when you mix various chemicals together? That these are these fundamental research questions, and we don't know what the answers are. Now, obviously, there are certain kinds of research that does have some kind of commercial appeal, and there are plenty of private companies that are willing to spend lots of money to try and solve problems that are relevant to their businesses. And, the pharmaceutical companies are a good example of this, that they spend tens of billions of dollars a year on research trying to figure out new drugs that they can then commercialize. But most of the big advances in our overall level of science have come from basic research. What companies out there would be willing to spend tens of billions of dollars to understand the very nature of gravity? right? Like, what does that get you? Like anti-gravity? Probably not. And yet, as we better understand gravity, then maybe down the road, we'll come up with something. So often the payoff for this basic research is decades later, even centuries after, is when we finally get this. And the nations that invest the most amount in science are the ones that get the biggest payoff. It's like a very direct, like you can see that there is a multiple of investments in science that then turn into effects in the economy down the road. And the greatest example of this is the United States. Like historically, the United States is the biggest investor in science and has the most advanced nation on Earth. Those two things are connected. And so you can never expect that private industry is going to spend research on that kind of stuff. Like you'll get some for sure. Like, DeepMind spent lots and lots of money trying to investigate artificial intelligence. And so, yeah, there was some government spending on artificial intelligence, but most of it has come from private industry. So great, right? But other stuff, it's just, there's no value in it for private companies. And yet we depend on those incredible advances. So it has to come from some organization that isn't looking for a return on investment. And the only one that we've been able to come up with so far is government and, I guess, nonprofit charities. Keanan Mahoney, what is your opinion of renaming Uranus to Caelus? It's too late. It's got its name. There's no going back. So, and what do you do, right? Do you rename it to Caelus because you just think people can't handle it being a silly name? Is that what we're going to do? We're going to be like a nanny state? Can't people have fun? Can't people both have science and be giggly children? Can't we have both? I think we can do both. I think that we can calmly and coolly discuss the fascinating science on an ice giant planet in the outer solar system that we're only just learning, the slightest things about it, because we've only had one flyby from Voyager 2 that, all of our ongoing observations, we only just a couple of weeks ago finally figured out its rotation rate. It has some really fascinating moons. It is a serious place to study. And its name also sounds like a bum. Isn't that funny? We can, sounds like your butthole. We can do both. It's okay. You can say that we need to send a probe to Uranus to study its gas. It's funny because it sounds like a butthole. But also, it's an interesting scientific place of study. This is the name. And this is the one we use. And this is how we say it. And that could be your hill. This is the hill you want. That you just can't handle people being silly. Then you will just spend your whole life fighting. Just go with it. Just don't fight it. Julian Blake, what cool science do you know is planned for the European Southern Observatory's extremely large telescope, which is now being built in Chile? The extremely large telescope, which is going to be the follow-on telescope to the very large telescope, is a 39-meter telescope that is currently being built. It's expected to do first light in 2027, so it's really just a couple of years away. And it is it's the biggest telescope on Earth by far. There's a couple of other super telescopes that are going to be in the running. There's the Giant Magellan Telescope. There's the 30-meter telescope, although that's been delayed. But there's going to be this whole class of new giant telescopes. And when it comes online, it will be the most powerful telescope ever built. Bar none. It'll be more powerful than Hubble. It'll be more powerful than James Webb, although it'll sort of be different than James Webb. And it will be a ludicrously powerful telescope. And so what can it do? Well, it can do anything a telescope can do. It is just a super duper telescope. And so all of the kinds of operations that astronomers are going to use various telescopes for, this one will give them better resolution, will give them more light gathering capacity. It has all of the bells and whistles that all of the big observatories have. It has adaptive optics. It's got 8 lasers that come out of it. And so it can make all of these guide stars in the sky that it can then use to modify the underlying mirrors to be able to account for atmospheric distortion. So some of the things that it will be able to do, for example, is it will be able to theoretically observe Earth-sized worlds orbiting around sun-like stars. So, this holy grail of being able to see another Earth. Now, the challenge is that getting a coronagraph powerful enough to be able to do that is pretty tricky. And a lot of the underlying coronagraph technology has already been developed for the Very Large Telescope. These are the 8-meter telescopes, the 4 telescopes. But new images of exoplanets, just like anything telescopes do, just better. So there's a paper that we reported on Universe Today about a month ago where we were looking into, or someone posted a paper about how, for example, it will be able to directly image exo-Neptunes and exo-Saturns and exo-Jupiters and things like that, and exo-Earths. And that with just an hour of time, it will be able to characterize the atmosphere of a Neptune orbiting around another star. And with 10 hours of time, it should be able to characterize the atmosphere of a terrestrial planet orbiting around another star. So, these are just dreamed of capabilities for the astronomical community. So, it's a good thing that Vera Rubin is going to come and we're all going to get really excited about it, because the next big telescope that we're all going to get super excited about is going to be the extremely large telescope. Did you know that you could watch the same video with no ads for free and get a bonus question over on Patreon? We call it Q&A Plus. And this week's bonus question is all about what I'm obsessed with right now. All right, those are all the questions that we had this week. Thank everyone who put your questions into the YouTube comments. Everybody who showed up for the live show, our 2-hour live questions extravaganza, which we record every Monday at 5 p.m. somewhere in the world. So I'll put a link to where the next event is going to be so you can find that. Now, I'm going to shout out some more smaller science YouTubers, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Bray Lake Roofing, Brian Body, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, David Gilton, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smiths, Michael Purcell, Modsel, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler Munley, Vlad Shivlin, and Wolfgang Klotz, who support us at the Master of the Universe level. All your support means the universe to us. So I've been really trying to use my influence, my following, as a way to try and shout out other YouTubers out there. And I've got a few more picks this week to direct you at. The first up is Abdur Astro. And he does like telescope reviews. And he's someone who I stumbled onto while I was looking for more information about the Sea Star that I just purchased. And so he's only got 5,000 subscribers and yet has got just tons of content about different kinds of telescopes, the Sea Star, celestrons, and sort of lots of guides. So if you're into amateur astronomy, astrophotography, check out his channel. The next one is 1 Minute Geology, and these people only have about 2,400 subscribers, and yet they're producing an enormous amount of content. These short, really detailed geology videos about various places in the UK, mostly. And it's very cool because they sort of stand in front of a very interesting geological formation and then give you some very detailed information. It's very technical, but also really cool. And then the last one that I want to share with you is Tom Dune's UK Space News with only 1,600 subscribers. And so, there's a lot of space news about what's happening with SpaceX and also more about SpaceX. But there are other places where rockets are being launched. And there actually is a burgeoning spaceflight industry in the UK. And Tom covers different launch complexes, different manufacturers that are producing things. And it's great to see like that level of hyper specialization, but also like really well polished, good quality video, good narration. So definitely check that out. Again, if you know of small YouTubers who are producing great science topics, explanations, please let me know so that I can help give them a shout out here. All right, we will see you next time.